Hello. In this video, we're going to look at the different ways to arrange letters in a word. So let's start with a simple question. How many ways are there to arrange the letters in the word D-A-D? Now, when we're talking about arranging the letters, it doesn't have to spell an actual word. We're just looking at different arrangements of the letters. And so we could try to write them all out. We would have, of course, D-A-D, just putting the letters how they are. We could put A-D-D. We could try D-D-A. And then I think that's it. I think those are the only options I can think of. Okay, well, how would we come up with a formula to give us 3? If you remember from before, if we have the letters A, B, C, we draw 3 blanks. And we have 3 choices for the first letter, 2 for the second, 1 for the last letter. We multiply them, and that gives us 6. Well, here we have 3 spaces because we're making a 3-letter word. But we have, I guess, 3 choices for the first letter and 2 for the second and 1 for the last. But if we multiply all that, that gives 6. I don't know. This seems a little tricky. I'd encourage you to pause the video and see what you come up with. See if you can come up with a way of getting a shortcut, a formula for this answer of 3. All right, well, if you came up with a formula, let's try another example and see if your formula works. Let's say we had the letters D, D, and D. Well, for this example, I think we're only going to have one option, just D, D, D. Does your formula work for that? Maybe it does. Maybe it doesn't. Let's keep going. Let's keep trying different words and see if you can come up with a formula. Let's look at the letters of the word dada. Well, we have D-A-D-A. We could have D-D-A-A. I'd encourage you to pause the video and see if you can write out all the different options. All right, I'm going to keep going here. We'd have D-A-A-D. We could have A-D-D-A, A-A-D-D, A-D-A-D. Now, I think those are our only options here. We've got the one starting with D, the one starting with A, and I think that's it. So that's going to give us a total of 6. Now, this is really weird. I mean, maybe you have a formula that's working, but initially, to me, this seems very bizarre. Because if we had 4 letters, A, B, C, D, we draw 4 blanks, 4 times 3 times 2 times 1, and that would give 24. How in the world do you go from 24 down to 6? I mean, it's clearly less, but like, how do you come up with it? It seems really strange. It seems like there's almost no connection. But let's go back and let's write out what we have. If we have DAD, that gave us a total of 3 different options. If we had DDD, that gave us a total of 1. If we had DADA, that gave us a total of 6. So we have some data, and we're trying to find a pattern, a connection, a formula that would work for these options. Now, what I'm going to recommend is we start with the full version. So just like here, we know the answer is normally 24. Now the question is, how do we get back to 6? We know with 3 letters, the answer was normally 6. How do you get back to 3? And again, the answer with 3 letters would normally be 6. How do you get down to 1? So I'd encourage you to pause the video and think about it for a little bit. See if you can come up with a way to reduce those numbers that we had. Here, let me do that in the same color. To reduce sort of the the standard numbers down to these new numbers. All right, so if you look here, this is divided by 2. 6 divided by 2 is 3. This is dividing by 6. This is dividing by 4. So it seems like we can get there with some kind of division. But, I mean, what kind of division? How does this work? And I think the key is to notice that dividing by 2 is actually dividing by 2 factorial. Dividing by 6 is actually dividing by 3 factorial. Now dividing by 4, let's pause on that one because 4 isn't a factorial. But so far, we've got a 2 factorial that we have to divide by, and we've got a 3 factorial. And I think this kind of makes sense because there's 1, 2 of the same letter. And the fact that there's a same letter, that repeated letter, it changes the options because DAD is going to be the same as DAD. Now, you can't see it here, but I actually switched the D's around, right? I put the first D in the back and the last D in the front, but it didn't do anything because we have the repeated letter. Switching the letters around doesn't do anything. And so we have to reduce the number of options in our formula. There's 2 repeated letters. We divide by 2 factorial and it totally works out. Here, if we have 3 repeated letters, right? 1, 2, 3. We could divide by 3 factorial. 6 divided by 3 factorial gives you 1. Now, let's just continue with that reasoning here. We have 2 D's and we have 2 A's. So let's divide by 2 factorial for the D's, and then let's divide by a 2 factorial for the A's. Well, 2 factorial is 2, so 2 times 2 is 4. If we're dividing by 2 factorial, it's like dividing by 4. Oh yeah, that works out. 24 divided by 4 will give us 6. So let's try to summarize what's going on here. If we have a word, DA, the way we find the number of arrangements is we start with 4 factorial because there's 4 letters, 4, 3, 2, 1. Then we divide by the 2 D's and we divide by the 2 A's. And that works out to 24 divided by 2 times 2, 24 divided by 4, which works out to 6, which is exactly what we found by actually writing them all out. All right, so let's take it up a notch with a word like Canada. How many ways are there to arrange the letters in Canada? Well, using the technique we just developed, we have a total of 6 letters. 1, 2, 3, 4, 5, 6. So normally it would be 6 factorial. That would be the normal way if all of the letters were distinct, if they were different. But of course they're not. In Canada we have 1, 2, 3 A's. So we have to divide by 3 factorial. Now to show you how to do this without a calculator, we can do 6 times 5 times 4 times and then stop at the 3 factorial. That way the 3 factorials can cancel. So that gives you, I guess, 5 times 4 is 20. 6 times 20, that'll be 120. There we go. So we have a shortcut. We're able to get the answer. It's pretty quick. And I mean, writing out all 120 different combinations of the letters, that seems like a lot. So let's see if we can use a computer to write them all out just to check. Because the formula seems good, it makes sense, it seems to give us the answer, but it would be nice just to confirm that this is indeed the correct result. All right, so here we have Wolfram Alpha, which is an online supercomputer. We typed in permutations of Canada, so it gives us the letter C-A-N-A-D-A. It says the answer is 120. And interestingly here, if we take a look, we can actually see all of the different options written down. Now it's going to take a little bit. I don't think they can all fit on the screen, but we can see here we have AAAA-CDN, AAAA-NCD, and so on. And there's a total of 120. So our formula checks out. The computer wrote them all out. We can trust it. It's really exciting. It's a way to get the answer really quickly. So go ahead and pick a word you want to try. Give this a try with any word you can come up with. Pause the video, see what you want to experiment with, and then I'll pick one as well. All right, my favorite word to do this with is Mississippi. M-I-S-S-I-S-S-I-P-P-I. Mississippi has a lot of letters and a lot of repeated letters, so it's a lot of fun. Let's see how many letters it has first. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. It has a total of 11 letters. So we start with that 11 factorial on the top. Underneath, we have to divide by, well, there's going to be 1, 2, 3, 4 i's, so 4 factorial. There's going to be 4 s's, so a 4 factorial, and there's going to be 2 p's, so 2 factorial. Now with a number like this, there's no way we're going to be able to do this mental math. The numbers are just too big. So we can type it in on our calculator and see what we get as a final answer. So if we do that, it gives me a total of 34,650 different options. Those are the different ways you could arrange the letters in the word Mississippi. So again, let's go ahead and take some notes on this idea that we learned here. This we could call arranging letters in a word. And so the idea is if you have n letters, then you get an n factorial. But if you have m repeated letters, then you have to divide by m factorial, giving you n factorial over m factorial. So that's the basic approach. You just count all the letters and you put that factorial on top, count all the repetitions and put it on the bottom, and away you go. So let's take a look at another word as an example here for your notes. Why don't you try the word banana? So go ahead and pause the video and see what you get. All right, so there's 6 letters, so 6 factorial. There's going to be 3 A's, so 3 factorial. And there's 2 N's, so 2 factorial. Now, if you simplify that, you should get 6, 5, 4, 3 factorial over 3 factorial times 2 times 1. The 3 factorial cancels, and we can reduce the 2 with the 4 to make it a 2. 5 times 2 is 10, and times 6 is 60. Now for some more practice, I'd encourage you to include an example from worksheet 3 or 3.5. And then you can write down any things to remember. All right, hopefully you enjoyed this video, and as always, thanks for watching.